Lists sometimes have numbers all over the place. Sometimes you just need an average, mean, median, or mode. Today we're looking at some tricky and hard applications of mean, median, and mode. But first, let's start with the basics. Mean is the average of all the terms, sum divided by number, right? Mode is the most common term, so if you have a list of numbers, the one that appears the most number of times. And keep in mind that there can be multiple modes, in which case, if there's a unique mode, there's only one mode, right? Because you could have two of one number and two of another number, and everything else only one of. In that case, there would not be a unique mode, but a unique mode means there's only one number that's the most. Median, if you arrange all the numbers from decreasing to increasing, the median is a middle number if the number of terms is odd, but if the number of terms is even, then the median is the average of the middle two terms, because there's no one middle term. There's no one middle term in when you have an even number of terms. So for example, in this case, the median is the average of these two terms, right? Okay, and range is just largest number minus smallest number. Let's take a look at an application of this seemingly simple concept. Let S be a list of positive integers, not necessarily distinct, in which the number 68 appears. The average of the numbers in S is 56. However, if 56 is removed, the average drops to 55. What's the largest number that can appear in S? Okay, so 68 appears in this list. The average is 56. However, if you remove 68, the remaining numbers have an average of 55, right? The average of the remaining numbers is 55. So these numbers all have an average of 55. Let's say there's n of these numbers. So n numbers have an average of 55. Okay, but all numbers combined have an average of 56. So n plus 1 numbers average 56, right? That's what's given in the problem, where we're saying that there's n numbers here and one number here, so n plus 1 total numbers that have an average of 56. Oh, but we know that so what is the total sum? Sum of all numbers. Well, one way to do this is there's n numbers that have an average of n, so 55n plus 68. Another way of putting this is that all n plus 1 numbers have an average of 56, so just 56 times n plus 1. Setting these equal, we get 56n plus 56 equals 55n plus 68. Okay, and this means that n, we can solve this equation to get that 56n minus 55n equals 68 minus 56, n equals 12. Oh, so that means we know that these are 12 numbers that have an average of 55, and 13 numbers, there's 13 total numbers that have an average of 56. Cool. But now the question says, positive integers, not necessarily distinct. What's the largest number that can appear in S? So we already know one number is fixed. These numbers are not fixed, so the goal is to maximize one of the numbers. Just one of the numbers we have to maximize. So if we're trying to maximize one of the numbers, let's make all the other numbers as small as possible. There's 12 numbers over here. This number is fixed, like I said, we can't change it. There's 12 remaining numbers that we can choose to be whatever we want, such that they have an average of 55. And if you want one number to be really big, such that the largest number is higher because it's asking for the largest possible number that can appear in S, let's let all other 11 numbers to be just 1. Yes. $11. Okay, remember, it says positive integers, so we can't make it like negative 100 or 0 or anything like that. 1 is the smallest possible value for the numbers. So now, for the average of all 12 of these remaining numbers to be 55, if we have the total sum of all of those 12 remaining numbers is 12 times 55, which is 110 times 6, 660. So the sum of all of these numbers is 660. and 11 of them are 1. Because as you can see here, 11 of them are 1, so we can maximize this other number. So 660 minus 11, 649 is the largest possible value for this number, and therefore our answer. Let's quickly review. The first step was saying that we don't know how many numbers there are, let it be a variable, n. And then we came up with this systems of equations to solve to get n equals 12. And then after that, 12 numbers here, 13 numbers total. We saw the sum of these numbers is 660. Let's let 11 of them be all 1. So we can make this number as big as possible, which turned out to be 649. Let's move on. By the way, you can check out these written examples and solutions in the free Mastering AMC 8 book. Link will be in the description of this video for you to check out. Cool, okay. Median of the following list of 40 numbers. 1, 2, 3 till 2020. 1 squared, 2 squared, 3 squared till 2020 squared. Okay, so these squares, automatically we know they're going to be a lot bigger than these regular numbers, right? After all, squares are going to, the number multiplied by themselves, so they're going to be a lot bigger. Most of the squares are going to be bigger than these numbers. To be clear here, what is the minimum square that's bigger than all of these 2020 numbers? Well, if you remember my squares video, you know a quick trick to calculating squares quickly. So you can see 40 squared, 1600, right? That's too little. 45 squared, you can use the squares trick, 4 times 5, 20, then 25. Okay, so 45 squared is bigger than 2020. So that means that, let's write that out for a second. 1, 2, 2020. Remember, we're looking for median, so we're trying to figure out a way to order the numbers in some way. That's why we're looking for what squares are bigger than all these numbers. And notice how 45 squared is going to be bigger than 2020, right? And if 45 squared is bigger than 2020, so is 46 squared and 47 squared, all the way till 2020 squared. All these numbers are bigger than the numbers from here. Okay, median, first of all. Remember, even number, there's 40 numbers, which is even, so median will be the average of the middle two numbers. And because there's 40 numbers, median will be the average of the 2020th number and 2021st number. The average of them, right? So what is the 2020th number and what is the 2021st number? Well, as you can see here, most of the squares are bigger than all of these numbers. Some are not. The squares from 1 to 44. So basically, we're trying to find out what is the 2020th largest number in this list and 2021st largest number in this list. Okay, so 1 squared. Well, notice here how we still, in this list that we've drawn over here, we still haven't put all the squares from 1 to 44. But the key thing here is that 1 to 2020, 1 squared, 2, 1 squared, 2 squared, 3 squared, 44 squared, all of these squares are less than 2020. 44 squared, using the squares trick, is, you can watch my squares video on my channel if you don't know how to calculate these squares mentally, is 1936. And that's clearly less than 2020. Okay, so it seems like these numbers are way bigger, and then these numbers are all less than these numbers, of course. So, but how many such numbers have we got here? There are 2064 numbers here, right? 2020 plus 44. So the key idea here is that it's just a little bit above 2020. So to find the 2020th number, it's going to be one of the larger ones of these numbers, if that makes sense. So we know 44 squared is 1936, so we know that from 1 to 1936, and 1 squared to 44 squared. And then we know that these numbers are all going to be less than 1937, 1938, so on until 2020. We know that's true, right? Because 1936, 44 squared, they're equal. So all of these numbers, because 44 squared is 1936, so, and all the squares less than 44 squared will of course be less than 44 squared itself. So therefore, these numbers are all going to be greater than all of these numbers. Interesting. So how many numbers are here? Let's count. There's 1936 numbers and 44 squares. 1980. Okay, interesting. So 1980 numbers here. We're looking for the 2020th and 2021st numbers. Okay. So from here on out, you can think about it as these are all the smaller numbers. Then we have these numbers in between. And then we have all the larger numbers. If that makes sense. Let's move this a little to the side. Whoops. So we notice how all the squares from 45 squared to 2020 squared, they're all way larger. Like you can draw these lines here. 45 squared, 46 squared, so on. All the numbers on the right side are much larger than all the numbers on the inside, which are much more than all of these numbers here. So the median is going to lie somewhere here because there's 1980 numbers here. So the median will be the 40th. In order to find the median, we need to find, remember, the 2020th and 2021st terms. So we essentially need to find the 40th and 41st numbers from these ones. And if 1937 is the first number in this list, then the 40th number will be 1976. Because first 1937, you can imagine that. And then 40th, we add 39 because we're just increasing. Notice how plus 1, plus 1. So to get to the 40th number, we just add 39. So you can also think of it as arithmetic sequence we learned in the previous a few videos ago. So 1937 plus 39, 1976. That's the 40th number. 41st number will be 1977. And those are the 40th and 41st numbers of this list, but they're also the 2020th and 2021st numbers of the whole entire list. So our answer is just 1976 plus 1977 by 2. You guessed it, 1976.5. And we are done. So the key idea in this problem was noticing these kind of three groups of numbers. And then from there, we can see that all of the numbers on this side are less than the ones inside here, which are less than all of the ones here. And we found that by seeing 45 squared is more than 2020, so all these numbers are way bigger. 44 squared is 1936, so these numbers are all going to be less than the ones in the middle. And the median lies here, and from there we just use a little bit of logic to find out what the two numbers which are going to be used in the median are. And then we're done. Cool. Let's try an example of mean, median, mode, and range this time of a collection of 8 integers that are all equal to 8. Okay. Mean, median, unique mode, and range. Okay, so let's focus on median first. Why do we focus on median first? Because range, there's many possibilities. Mean, there's many possibilities. Unique mode, again, there's many different possibilities. But the median only has so many possibilities. Remember, because there's 8 numbers, the median will be the average of the middle 2 numbers, the 4th number, and the 5th number. So for that to happen, the possibilities are, it's 8 integers are all equal to 8. We can have 8, 8, 7, 9, 6, 10, right? The average just has to be 8, and so on. But consider what happens if, let's say, we chose 7, 9 or something like that. If these middle two numbers were 7, 9, then all these numbers are 7 or less, right? Because we're assuming the numbers are sorted. Because remember that median is the average of the middle two numbers when sorted. So assuming all these numbers are sorted, all of the numbers over here are less than or equal to 7. All of the numbers over here are greater than or equal to 9. But then the unique mode is 8, or is 8 equal to 8. But there's no 8 here. All these numbers are less than or equal to 7. All these numbers are greater than or equal to 9. There's no 8. So there's no way it can be the unique mode. And the same goes true for 6 and 10. In this case, all these numbers are less than or equal to 6, greater than or equal to 10. There's no 8 anywhere. So then what must be true? These middle two numbers must be 8 and 8. And that we've already found a very valuable piece of information with median. Cool. Unique mode and range. So we've used that median. We can do a check mark little there. Now we have to use range, unique mode, and mean. Mean is okay. We're asking for the largest possible integer. And remember from the previous problem, when we're trying to find the largest possible integer, we want to minimize all the other integers. So again, mean has many possibilities. Unique mode, we've already kind of dealt with here, but the thing is there could be, unique mode says there could be more 8s on either side, right? There could be maybe like an 8 here or an 8 here or both. Because you cannot have an 8 somewhere here with another number like 9 in between. Remember, we're assuming these numbers are sorted, increasing, decreasing. But we'll worry about that later. Now let's focus on range. Range. So range 8 again means largest minus smallest is 8. So what are the possibilities then? Oh, but we're looking for the largest possible integer. Interesting. So you can have something like 1, 9. You could have something like 2, 10. So the key thing here is we're trying to maximize this element, right? The largest integer that can be in this element. So the maximum value of this element. But if this is x, or let's do the opposite. If this is x, this is just x minus 8. So to maximize this element, we also have to maximize that element. So we want to make both the largest and smallest as big as possible, but the other elements in between as small as possible. The other elements in between have to be as small as possible. Why? Because then the mean is another constraint, right? The average is 8. So if we make these numbers and these numbers really big, then the largest number and the smallest number will not be able to be as big, if that makes sense. So, okay, so what are the smallest possible values for both of these numbers? They both have to be greater than 8, of course. So greater than or equal to 8. So why not just make them both 8? After all, they can't be like 1 or 2 because this is increasing order, remember? So the minimum possible value is 8, so just make it 8. Okay, now what about these numbers? The minimum possible value for those numbers is just going to be equal to the minimum number, x minus 8. Why? Because these two numbers have to be greater than or equal to that number, and the minimum value is when they're equal, because you don't want them to be way greater than, right? So now we have that these are our numbers, and they have a mean of 8. Let's now use that condition. Mean of 8. Okay, so if 8 numbers have a mean of 8, the sum is 64. So sum equals 64, because mean is 8. And that means, what is the sum? 3 times x minus 8 plus 32 plus x equals 64. 3x minus 24 plus 32 plus x equals 64. Subtract 32 from both sides. Add 24 to both sides. Simplify. Solve. X equals 14. X equals 14. Okay, so does that work? X is 14, and these three are all 6. Now, we've already solved the problem, and by this, our answer should be 14, but just to make sure, let's check it verifies all our conditions. Okay, mean 8, right? The sum is just 3 times 6 plus 4 times 8 plus 14, which is 18 plus 32 plus 14, 64. And the sum divided by 8 equals 8, which is the mean. So check. Median 8. The middle two numbers are both 8, so check. Or I already made a check, so another check. Check mark. Unique mode 8. There's 4 8s and the next height, and there's 3 6s and 1 14th. Well, there's the most number of 8, so check. And range 8. 14 minus 6, check. Our answer is 14. We've confirmed it. Is this truly the largest possibility? Yes, because we've minimized these terms, so the sum is as big as it can. The sum is 64, and because these terms are as small as possible, the largest term can be as big as it truly can be. And now let's just quickly review everything we've done in this problem so far. First, we have to check out the median condition, and we saw that the only possibility is both middle terms are 8. The other possibilities don't satisfy the unique mode condition. And then after that, we saw that the range condition. And we noticed that to maximize the largest element, we want to minimize. We also want to maximize the smallest element, but minimize the other elements in between. And to do that, all we had to do was set these elements equal to that, and these elements equal to that, because that makes it as small as possible. Remember, this list is increasing list. Increasing list. So, next step. The next step from there was to let them be variables, x minus 8, solve for x, which was the answer, and then see. Indeed, it does work. It satisfies every condition, including range. And that's it for this one. You can find these practice problems in the free Mastering AMC 8 book. You can download it. It has many, many problems, probably thousands by now, and written examples, and these problems as well that we just covered. So telescoping is, in my opinion, is the coolest topic. I mean, you can convert super complicated expressions like this and just cancel everything out, literally like that. We'll explore telescoping in the next video, right over there.